Hey everyone, welcome. This is another installment of the Build with Celo workshop. Tonight we'll be building an exchanger Celo using Solidity, Celo Composer, and Fiat-connect. With me is Kenny, Aziz, and Habib. And tonight will be the first installment of the workshop, and they'll be taking us through, building out this application live with Celo Composer and Fiat-connect. So, uh, Kenny, if you don't mind introducing us and kicking this off.
Hi everyone, my name is Femi, and today I'll be taking us through how we can write a smart contract, build a smart contract that's going to serve as an exchange smart contract on top of Celo using Solidity and Celo Composer. Today would be focusing on writing like the old smart contracts, writing the test, testing it out, and also deploying it on Celo testnets, Alpha Juris. So this is the example. This is the example of what we're building. The UI for this code, the front end for this code is already is made available on GitHub. So we are going to share like the code so that you can clone it. The front end is also with Celo Composer. It's built using Next.js React. As you can see, on the left is the mobile view, and on the right is the desktop view. The whole idea is once the user signs up on the app, an address will be generated for them, like a wallet address will be generated for them that they can use to hold any of these tokens, Celo USD, Celo Euro, Serial, and then they can receive any of these tokens inside of it, and they can transfer it out, and they can deposit into the app also by transfer or also by Fiat-connect. So as you can see, as I mentioned, these are like the list of features of what the whole app is going to be. You're able to sign up, log in, create wallets, show balances, deposits using Fiat-connect, deposit using crypto, transfer out to a crypto wallet address, withdraw, and then you can view your transaction history. Although this session is split into two. Today's session is focused on building smart contracts and deploying. Tomorrow's session will be focused on building like the API. Won't be talking about building the front end at all because the code is already made available and you can easily clone that. So what will you be learning? You'll be learning how to build front end using Celo Composer, Next.js, React. You'll be able to learn on this workshop how to write upgradable smart contracts. You'll also be learning how the proxy pattern work. I mean, for those that have used upgradable smart contract before, there was a session yesterday that happened for those that have used upgradable smart contract before. You would know that it uses like the proxy pattern method, and everything has been made easy using OpenZapling. But what if you also have to use that pattern while writing your code base tool? How would you do that? You would learn that today. And you would also be learning how to build a custodian wallet. I'm sure you must have been imagining once in a while that when I use Binance, when I use this custodian exchange where I don't have to keep my mnemonic, I don't have to keep my private key, how do they achieve this? We'll see how one of the method in which this can be achieved, and we're going to code this out. This is going to be a live coding session. And we are also going to be showing you how you can use Fiat-connect. There's been a lot of questions about how you can build an API that conforms with Fiat-connect to on-ramp and off-ramp on Celo. You're also going to learn that. That will be a session. This session will be for tomorrow. And also, we are going to write tests for your smart contract. Our smart contract, after writing and deploying our smart contract, we're going to write a test to see that it behaves the way we want it to behave. We're going to be using the ADA framework, and then we are going to be using Kai and the ASATs to actually write our test. And also, we are going to briefly touch on Sleuter. Sleuter is a tool used to check vulnerability in our smart contracts. After writing smart contracts, it checks our smart contract against like common vulnerability, for example, reentrancy and a lot of things like that. And we're going to briefly touch how that works, and we would deploy our smart contracts on Celo Alpha and we are going to verify it. So you're able to view the code live on Celo Alpha. All right, so we would get to the coding part now. Ernest, please switch my screen. All right. Okay. So first thing first, for those that decide to follow along this code, you can find this code publicly on GitHub by following this URL. Right. I'll paste it right here in the private chat. I don't know if that works. But this is where you can find it. You can find it. This is the organization name. You can find it. And once you do that, the first thing is I want you to clone, because this is going to be like our starting branch. Give me a moment. Most have that is the wrong one. The right one is this. Let me copy this and paste it again. Copy link address. That's for the first one that I sent is for the front end. This is for the smart contract itself. First one I sent is for the front end, so it's not bad. You could just find it on GitHub and clone this. Once you clone this, the first branch you want to like start with is 001 Solidity contracts. It has all of everything to like start with inside, so we don't have to like go through the whole setting of Celo Composer. All of those like bootstrap parts is already there, and there is a README inside like the contract folder which we'll be following. It makes things easier. It's from step 1 to step 5. And as you will see, if you check like the branches that we have from branch 001, 00 to 003, 004, 005. So at some point in time, if you're following these steps and you are not getting it or you miss it, you can always just check out one of these branches to see how it's being done. Or if you're not live coding, you just want to be following up, you can just be checking out from 001, 002 as I'm moving from one step to the other. All right, so right now I already have like branch 001 right here, branch. Yeah, what I did was just, what I simply did was check out the branch from 001 so we can use for this. All right. So the first question is, how do we represent a custodian wallet? Now, the app that we want to build, as I explained, is going to be a wallet whereby, like an exchange, basically, whereby our users can sign up, right? An exchange is basically, just like Binance, users sign up, they log in. Once they log in, they have their wallet address. They can hold their wallet in it, and it means that they don't have to keep their private key and mnemonics, all of this. They don't have to keep it by themselves. The exchange does that. All they just have to do is just log in, transfer token, keep token, deposit, do all of the things that they have to do. I mean, if you're familiar with Binance and other exchange, you would know this, right? So one method which is like the most common or would think of first is to generate mnemonics and private key for every user that signs up on our platform, right? So it means that if we have 1,000 users that signs up on our exchange, we need to have 1,000 private key or 1,000 mnemonic, and that's can tend to be a problem because it might not be scalable, right? Because now it means that we have to worry about securing about 1,000 private key, and then it goes on and goes on like that. But another strategy which we will be using on this workshop is to deploy a smart contract as a wallet, right? Which is smart because a smart contract basically can act as a wallet, right? And in our own case, we are going to have one factory smart contract deploy new smart contracts as a wallet for each of our customer that signs up. And we are just going to allow that one single smart contract to be able to control the rest of our smart contracts. It means that we have to just focus our security on just one smart contract, which we'll be calling the factory smart contract. So that way we don't have problem, we don't have to worry about the problem of managing several keys, and we just have to focus on our factory smart contract and make it secure. And once that's secure, our factory smart contract controls all of the smart contracts that will be serving as wallets. So for if we have 1,000 users, we have 1,000 new smart contract deployed, right? And we are going to have to define a wallet implementation, right? A wallet implementation is just a smart contract that is going to hold um, all of the functions that our wallets should be able to do. For example, we can get the version of our wallet, we can transfer token from our wallet, we can get the balance, we can stake, we can do all of those things. We'll have a wallet implementation that does that. And also, we are going to have another smart contract called wallet proxy. All right. So, what the wallet proxy does basically is that for every new smart contract and every new wallet that we deploy, the wallet proxy will serve that purpose for every new smart contract that we deploy. And the reason why we have to use a wallet proxy is simply because if by today we deploy if by today a new customer comes and they create an account, a new smart contract is deployed as a wallet for them. And tomorrow we need to add new feature to support those wallets. I mean, we need to be able to be compatible for those new users, right? So that way, the way we are able to solve that problem is to make a wallet implementation like where we can increase the version 1, version 2, version 3, and we would have a wallet proxy that calls our wallet implementation. All right. I mean, it calls our wallet implementation every time, in order to, for example, if we want to deposit, it calls the deposit from here using delegate call. It calls it every time. So we can always change our wallet implementation as much as we want, right? So far we write our smart contract well, we can change it as much as we want. And our future users and our old users can always enjoy the same features every time. All right. Now, another problem comes that, when we deploy our wallet proxy, it knows the implementation, right? Now, if we change the implementation in the future, how does the old one knows which implementation to call? And that is solved by defining the wallet implementation inside our factory, all right, which we are going to say soon. So let's get right to work. So the first thing we'll do is create a proxy contract. So in order to do that, I'll be making use of open source wallet proxy smart contracts. And there's the notion that when you are trying to build a smart contract or trying to write a smart contract, and the smart contract is already open out there and is already audited, it just makes sense to use that, right, as opposed to trying to write your own. So here we would copy this. This is a proxy contract that OpenZapping has. So we are going to copy this. Now go to our code. I'm sure by now we would have cloned up this. So come to contracts, click on new. Here, let's do wallet proxy.sol, and we'll paste this. Now, before I proceed, there is one thing that has to be done, which is you need to run yarn install right inside the other folder, inside packages other folder, yarn install, so you can have like your node modules updated and you have like all the package.json file. And you also need to create .env file, right, inside adats folder. And your .env file, we have private key, which will hold the private key right here that has Celo token in order for you to be able to like deploy to Celo Alpha JS. So you can get like Celo testnet token. You can always you can always just Google for Celo facet, right? The Celo developer facet, and you can always go and get test token in order to make this work. All right, so back to this. Now that we have this, our own version will be 0.8.4. All right, and abstract here, it's not going to be abstract. Yeah, an abstract contract, because for an abstract contract we cannot instantiate an abstract contract. In our case, we want to do so. Wallet proxy right here, and we have delegate here. We have implementation here. We'll flesh this out soon. We have fallback here. It's not going to be virtual. We don't intend to override this in any way. It's not. This is not going to be virtual tool. Same thing for this. So let's try to understand like this a bit, this smart contract, what it does a bit. So for the wallet proxy right here, basically, like I said, it's going to serve as the wallet that will be owed for each of our customers. And in that case, it's not going to hold any method at all itself, but it would be getting its method from wallet implementation, which is it's going to be calling by delegating call. So yeah, we have to we have two fallback functions, standard fallback function of Solidity. Here we have fallback and then we have receive. Now, fallback in this case, what it does is if this smart contract is called and data is being passed, in this case, it means that if a function that does not exist on this smart contract is being called, right? And the EVM looks and the function is not available. What it does is fall back to this function because data is being passed and call whatever is here, right? For receive fallback, it means that if this smart contract is being called and data is not being passed, right? It's going to call receive. Now, in our case, these are both useful. We want this receive, but we don't want receive to call fallback because receive will only be called when token like Celo native token is being sent to this smart contract. So we just want that token to stay there. All right. We don't want anything to happen. Like it's just like a sync. So once they send it, it stays there, nothing happens. It just receive the token. Doesn't take further action. Right. I mean, you can decide if you want to do other stuffs. Maybe you want to try to log the event using graph protocol so that you can build your API around it. Maybe just log an event because the gas here is very limited. Just maybe log an event. You can do that. But in this case, we don't require that. For fallback will be called here. When fallback is called right here, which is like an internal function, it's going to call before fallback right here. We are not doing anything before fallback. No need to remove it. We are not doing anything. But if you want to do it like a check or something, you can do it there. And then we call delegates. And what it simply does is delegates the implementation, delegates the call to this implementation now. And here we did not define our implementation. And basically, what we want our implementation to return, like I mentioned earlier, we want it to return the address of our factory. Return address of our factory, right? So in our case, let's call it Exchange Factory. We need to, in this case, it's not actually return the address of the factory. It has to return the address of our wallet's implementation. Beg your pardon. And for us to get the address of our wallet implementation, like I said, our wallet implementation is being held. Like our factory knows what our wallet implementation is at every time because we have to be updating our wallet implementation every time. So for now, let's just address this for now. Like it's nothing. Let's just address this for now. Let's address this for now. So you realize that once I did Control Save, he actually like kind of like using prettier formatted all of this stuff, and that's because this is also included in the repo. All of these settings too is there, so you'll be good to go. And I'm using VS Code. Let's address this for now. So let's go back to what we want to do, our steps that we are following. Now that we have our proxy contracts added, we also say that we want to create our Exchange Factory. We want to create our wallet implementation and this. So let's go ahead to that Exchange Factory, our wallet implementation. So our next thing is create our exchange factory dot sol this defines contract definition. Right, exchange factory. Right. And we can only just copy this XPDS license and all of these things and bring it from here. Right, we have our exchange factory, and the next thing is we want to create our what? Wallet implementation dot sol wallet implementation. Right. We should also copy this. No, no, no. Now we have our wallet implementation, right? We have all of these defined right here. Now, as I mentioned in our wallet proxy, if we, the implementation for our wallet would be this wallet implementation. So we need to get it from our exchange factory. So let's define that first, which means that we'd say that okay, we have address of uh, wallet implementation, and it's going to be public, right? And now, two things here. We can, while deploying our factory, we can first deploy our wallet implementation and pass our implementation to our factory, or we can simply not pass in this constructor and define a function to set our wallet implementation. But I will do both. Address wallet implementation, right? And then we'd say wallet implementation equals wallet implementation right here. And like I said, let's define a function. Say, okay, update wallet implementation, and it's going to be an address implementation this way, and it's going to be public, and we can just return bool like it matters, and say that okay, anytime we call this, so in the future, if we have version 2 of our wallet implementation, I mean, for example, version 1 only has maybe deposits and withdraw, and version 2 now has withdraw, and version 2 now has like staking and all of those functionality. We would just swap like, the wallet implementation so that our proxy knows anytime our proxy is being called, like the wallet is being interacted with, it knows where to update the latest code. So, and we just return return true. Right. So now back to our wallet proxy. What we'll do is we'll say, okay, now let us import our chain factory and say, okay, all right, here too, in our wallet proxy too, would say we have an address for our factory. At least we need to know the factory that we have to call. And our factory here, as you will see soon after this, is going to be an upgradable smart contract. I mean, we're going to handle that using OpenZapling. So it is safe for us to define the address of our factory directly inside our proxy because it's the proxy address that will eventually be referencing because OpenZapping handles all of the like the upgrading parts for us because we are not trying to undo that. Unlike the way we are handling the proxy and the one implementation, where we are doing the whole proxy pattern thing ourselves. For the exchange factory, as you see soon, that will be handled by OpenZapping, and so we'll be fine. All right, so yeah, I would say exchange factory here. Let's make it public. Nothing hot, it's just an exchange fabric. And then we have a constructor too. Constructor, pass the address and say the exchange factory is being passed right here. So we say exchange factory equals exchange factory, right? And yeah, we'd say okay. For us to get our wallet implementation here, we'll say our exchange factory this guy, exchange factory, which we can pass exchange factory. Okay. So here we call it what? Wallet implementation. So I hope this makes sense, right? From our exchange factory, where you have our exchange, we can use the address here to get these and it gets a wallet implementation. So it means every time you can always get a wallet implementation from here. So if it's the old one, if it's the updated one, version two, it always gets it. So we don't have to worry and we know this is exactly fine. So now we have exchange factory defined, we have a wallet proxy, we have a wallet implementation defined right here. Let's see what the next step is. So we have exchange factory, wallet implementation, wallet proxy. Um, so we have to install these two libraries. We'll be making use of OpenZapping contract and OpenZapping contract upgradable. Now, for those that you don't know what this is, OpenZapping provides like a library of contracts, reusable contract that we can use to write our smart contracts. They're all audited and make things like go with speed and with Swift. So in this case, we just to this might take a short while, but it should be faster for me. We should just do yarn add this guy. And what I should have just done is include. I just did the unhard for both, but then well, to be fast. So while this is running, I don't know. Does anyone have like a question? Is there any question that anyone has that wants to be asked? If anyone has a question, if you can type it in the private chat, I can answer your question. Okay. If there's any question, I'll be happy to like answer that now while this is running. Okay. We also have to do yarn add. What's happening? We need that too. Okay, that was that was fast. Now we need to convert our Exchange Factory into an upgradable version of it. So for us to do that, I want to make a reference to Open Zeppelin. Open Zeppelin has a doc that follows this outright upgradable smart contract. So in order to make that happen, the first thing you have to sort of like import is this. I'm sure this also has been touched yesterday during the last session about outright upgradable smart contracts. So we come to Exchange Factory right here. We do import this and we say Exchange Factory is initializable. Now the thing about upgradable smart contracts is that they do not have constructor like this. You have to change your constructor to an initializer. So you can simply just do initialize. That is correct. Let me see. I don't want to spell that wrong. Yeah, initialize function. After doing that, we also need to pass a modifier to our initializer. We need to pass a modifier to it called initializer. That's basically how you know opens the you would have to do it. And the reason for adding this modifier of initializer is that for the initialize function, it is public and it can only be called by the owner of the smart contract and it can only be called once. I mean, you don't want a case whereby you do not add this, right? This is like another bug that can happen. You do not add the initializer modifier such that your initialize function can be called, right? Twice, and that'll be a problem. It means that someone else can just, set your wallet's implementation to something else and they can, steal your user funds. So we just did that. And it means that whenever we want to be doing importing any open Zapier library for this particular smart contract, it has to be like the upgradable version of it. We cannot use like the normal version of it. So that is being done. Let's move to the next step. Next step here is install this, and now we need to add the following implementation. We need to add the following method to our implementation smart contract. We need to add version, so that will be fast. So come to our wallet implementation right here. Our wallet implementation does not have the constructor of its own. So we'd say function version is public, pure, and returns string memory. We always have to add that. And we'd say return E1.1.0. Very straightforward. Awesome. Second that we want to add is we want to add ERC20 token balance. This way. Now, ERC20 token balance. Now, the reason why we want to do this ERC20 token balance is that we would want to, for example, know like how much. If you want to know, for example, how much CUSD token does this wallet hold? How much CURO token? How much UBA token is here? How much PAC token is here? And we don't want to make it fixed. We want to be able to do it such that in future, no matter how many tokens is being out there, it's just easy. We just have to pass all of this. I mean, anytime, because it's an exchange. Any token can be sent to that wallet anytime. So we want the user to be able to withdraw it anytime. So far, we're able to add that to it. So yeah, so 20 token balance here. So the first thing we take is address token, right? And yeah, that's it basically. So what is the token? What's the contract address of the token, right? And yeah, we want to return unsigned 256, and it's going to be public. All right. So we're going to say return. Now, how do we call the balance of method from that smart contract, right? What we have to do is we need to import the interface smart contract to uh, be able to call that method, right? So in order for us to do that again, we'll make use of OpenZappling. So OpenZappling has all of these utility things that are available. We go to OpenZappling contracts and let's come to this utility interfaces. The interface we need here is IRC20. Yep. So yeah, we just need to copy this. This is what we need. Now we already installed the Open Zapling library, so it's not a problem for us to just do this. So we bring this in, say, okay, yes, like this. And then if you want to see what's inside of this, if I check this out, you would see it's just defining the interface of how an IRS20 token should be. So a standard IRS20 token is expected to have all of these. So what we need to just call is balance of, so we are good. So we're going to say, okay, IERC20, wrap that in this token address, and we say, okay, dot balance of address this. Now you need to understand that address this right here would refer to the address of not this wallet implementation, but the address of this wallet proxy, which is the custodial wallet address. And that's because this wallet proxy is using delegate call to call this function. And when you use delegate call, it's going to call that function using its own storage and using like itself, like this address, this would refer to, itself. So let's see what error is this saying. Function statement can be restricted to view. Okay, public view. All right. I hope that makes sense now. So next is what other thing do we want to add? We want to say, okay, we want to get a Celo token balance, which there would be function, yeah, Celo token balance, right? To get Celo token balance, we do not need any address, we can only just get address, not necessarily, do not need to pass any contract address. Once times 256 here, return yes, is balance. That's it. Again, we want to call withdraw ERC20 token and withdraw Celo token. So with this, on our wallet, on our exchange anytime, we're able to withdraw any ERC20 token on wallet. So again, we need the address of that token, right? And after the address, we also want to get, okay, who do you want to send it to? Who do you want to withdraw to? So, and how much? Send it to 256 months. Just follow that same energy of using this. And it's going to be public. It's going to be let's say boolean, right? So what will happen here is again, I was in 20 token here dot trans Ah, so so it's going to be, let's see, what does transfer state right here? We have balance of here, we have transfer address and amount, which is our two and amount. So two amounts. Yeah, and we can just return true. So before I proceed, one of the things I want us to again check is, which we can check is, for our Celo token balance or for our AS20 token balance, we can say, oh, we want to make sure that the token is not equal to, you know, empty address. If that be the case, revert, which is wallet implementation invalid token address. Yeah, and we save. See what the problem is here? Does this work? Sometimes I get it wrong, but let's see, address. Yep, got it. So this is not going to be an empty address. Let's copy the same thing and do here. Jeez. Gosh. All right, we need to be sure that the token address is not an empty address. Now, other further checks that you would want to mention that why are we not performing is checking that the total and the amount is not valid. But most, I mean, it happens most of, or I would say all, to be safe, but I'm just trying to use most of the AS20 token implement inside their transfer function. They have this check. They already check for the two address is not invalid, the amount is not invalid, right? They already like do that check. So if we decide to do that check here again, that means you're having two require statements. And the thing about require statement is you increase the size of your code, like the size of your code. So you want to not be imploding your smart contract with a lot of request statements. And another thing that makes your code bigger is they are using a very long um, they are using very long require messages too. That is a problem. That's why you see here I'm doing WI, which represent wallet implementation. Instead of me writing the whole wallet implementation full, I use the WI. That's like really smart to do, and that's why we did that. If you're wondering. So now, what is the last thing that we want to add here? We want to add withdraw Celo token right here, which is going to be, if we want to withdraw Celo token, we just need to put the amount right here, and it's public, and the returns bool, and guess, and we can say, yeah, the amount, it has to be the toll first, address, toll, and then who do you want to transfer it to? And all right, we'd say, okay, um, toll dot transfer amounts, and return true. Now transfer actually it does revert itself, so we don't need to kind of like check and all. It does, if it fails it will revert and bubble up. So you can always get that. Yeah, what's the problem here? Send and transfer only available objects of type address type not. So let's make this payable. I mean, we can do it in two ways. We can try to just implicitly convert this to payable, or we can just do it like this, which this is shorter. Now, a problem that arises here is, yeah, although it's possible to call all of these methods right now, but then the problem is anybody can call all of the methods on our wallet smart contracts, and that's because I mean it's safe for people to check token balance, call Celo token balance, ERC token balance. That's no problem, right? But doing withdraw your 20 token and withdraw Celo token, that is just bad. So what we want is the only guy that will be able to control, as we said, that will be able to call our wallet should just be the factory that is going to deploy it. So how do we make this happen? We make this happen by just saying by adding a modifier. So we need to add a modifier that says only factory. So we have a modifier here. Says only factory. And it says, okay, require that. Now we need to define our wallet, our X factory. So require an X factory. Yeah, it's going to be an address, right? Is equal msg.sender. Let's see here. Whosoever is calling this. Sender. Let's hold on a bit here. Our wallet implementation is going to be called here. So our message your sender here right now will already be our wallet proxy. So our modifier should not be here. Our modifier should actually be in our wallet proxy. Yeah, our modifier should be here. Should be in our wallet proxy, not there. So it should be here. Just to explain that, like clearly, the whole idea is the whole idea is right here. S factory should be else. It should say. Let me define this wallet proxy invalid caller. Modifier body does not. Okay, it's not done, which should be this. Now, the whole idea is our wallet proxy contract that we have here will be callable by our exchange factory, right? Right here to callable. But once it calls it right here, the problem is that as a matter of fact, we probably don't need to add the modifier. We can just add it like inside of it. The problem is that once it calls it right here, and once it makes delegate call inside of here, once delegate call is done inside of here, the only thing happening is that once it makes delegate call, the message or sender from inside of wallet implementation right here has changed to message or sender of the wallet address. So if we put it right here and say, oh, message or sender should be factory. Message or sender is no more factory um, inside here. Once it's copying the code, message or sender is now the wallet address. So we can just make sure that is not the case. All right. So let's see. Which in this case, we necessarily don't have to do this. We can just bring it here, take this out, and right inside our delegate call, before like the old delegate call thing happens, we check that message.sender right here is our factory address. Now, while deploying our wallet proxy, we pass a factory, and we have to always confirm that our factory is being set in our constructor, and then we can make use of it. And let's see right here. Implementation is gotten. Yeah, we are good to go. All right, so let's go back. So we've added the following function exchange. So now another thing again that seems like a security that we have to make happen on our exchange factory is we have to make our exchange factory possible, and that's because in the future, because we try to make our point of failure a central point, which in this case we try not to have like multiple wallet phrase and all of those things. We try to make it a central point. And since we made it a central point, we need to also be able to say that what if in future something is happening to our central point? We want to make it possible. All right. I want to make it possible such that we can always pause the smart contract and nothing can happen again to the rest of like the whole system. So in that case, we need to make it possible. So to make it possible, again, we make use of open Zapping, and to do that, let's simply just come here and let's see. That should be under security. Again, possible. Right here and again right here, and we do this. Again, we say once we make our smart contract upgradable, the only way this can work out is we have to. So now possible upgradable. That should be it. P G R A D E A. Yes, that is it. So we say it's initializable and it's and possible upgradable, right? So we can say function definition posit, and it simply calls pos. You can again say bool and on true to public. So now let us deploy next. Let's write our function that will create a new wallet every time. So function definition right here. Which is function. We have a new wallet. Right here. And now, while creating a new wallet, we need to be able to, because once from our backend code, which we'll be writing with Node.js, once you call the new wallet on the smart contract, right, it is not a view function, right? It actually calls new wallet and creates transaction on blockchain that you have to wait for it to mine. I mean, something can go wrong on your backend code. On the blockchain will always work just fine, and you did not get a response, which is going to be, say, the address of a newly deployed contract, right? So what would make sense is if we allow you pass like a UUID, such that anytime with that UUID, you can always get that, oh, what is the wallet address of this user? This UUID could be maybe the MongoDB ID of your customer data off-chain, and then once you call it, it's going to give you the wallet address. So let's see. You pass the UUID you want to return, let's say the address, the wallet for, in this case, you won't be able to wait for it. So just bool, all right? And it's going to be public and memory again. All right. So let's say address is wallets is equal, make that work, address new wallet proxy is what we do here. So let's see. We need to bring the wallet proxy. We need to import it in here. Import wallets proxy. So address new wallet proxy. We deploy a new wallet proxy, and the wallet proxy has a constructor, which is what? The factory address, which is this, right? And that's how it's able to get implementation every time. So we say address this time. Now we say we want to keep track of all of the address. So we need to create a mapping to keep track of that. Mapping of string, which is the UID to the address. I would say it is wallets. It's going to be public, by the way. So you can say wallets UU ID equals a new wallet address right there. And you can return true that, oh yeah, this is done. That's it. Now, again, we are faced with another problem, which is now this is our factory, right? And our factory is supposed to be calling, it deploys a new smart contract and it can update our implementation. But we don't want a case whereby someone else is able to call our exchange factory. So in order to prevent that, we need to say that the only person that can call things like, initialize is already taken care of by this, right? But the only person that can call other stuffs like update wallet implementation, pause, our smart contract, new wallet should be the owner of this smart contract. So in that case, we want to use the ownable. We want to add a modifier that says only owner. So that way we can just simply just do this, which will help. Should be access. We can use access here. Ownable modifier only owner here. So yeah. So we'd say now again, this contract is an upgradable smart contract, so we cannot just use the normal open sapling contract. It has to be upgradable of its type. And I can show you why. Why is because if I come to upgradable down here, if I scroll down, you will see this empty reserve space put in place to allow future version to add new variable, right? So this particular thing has been taken care of. But if you look at like the normal one with upgradable, this will not be there. And if you dig deep and research more into this, you would see that's one of the problem of proxy pattern. If you do it wrongly, you can have memory, you can have variable in memory overlapping each other because I said in memory, in storage, beg your pardon. Because the way the EVM manage like the storage is it stores in stack when it's running, when it's executing a smart contract, it stores all of this in stack and stack zero, stack one, stack two, like that. And each one is 256 bits size. And for example, address will go into stack one because it's 256 size, and this will go next, this like that. So if you don't do the proxy right, you can have like things overlapping, like memory overlapping. For example, in our proxy, we defined X factory. In our implementation, let's see, we did not define that. If we define something else here, right, that is not this X factory, problem will ensue. And one of the way I really try to solve that problem is I try to leave state up so that I do not, because when we start upgrading our implementation, this doesn't have a problem. We can always, if we want to add more variable, this will be a problem. So I would leave state up and take all of variable into another smart contract, like an abstract smart contract. So in that case, for example, let me create another abstract smart contract and call it, in this case, I'll call it common wallets. That's all. And I would say abstract, abstracts. I can't really have a constructor. I don't know why this is doing so. So on wallet v1, to be honest, because you can do v2 and all of those things. On wallet v1, right? Just rename this. And like I said, I'll just lift state up here. So I can say is, let's do this first. Let's guide ourselves. Let me define this right here and import this here. So this should sort the matter. Let me just close this and open this again. So my editor won't show the error. Should know it by now. Okay, well, that's because I didn't do this. That's it. And same thing applies for our implementation here, just in case. Also says common wallet. So they have the same memory, the same storage layout now. Why, So in future we can just do, V2 like that, like that, like that, like that. So that works. Anyways, we have done that, and let's see what is next. Let me confirm this again. So we have enable upgradable right here. We have to say now. So enable upgradable. We have to pass only owner can call this guy. Only owner can call this guy, and no, only owner can call this guy too. Now that we have that, I mean, we've been writing the smart contract ever since. Let's try to compile. npx add compile. Let's see if all works just fine. Yeah, all of our smart contracts compiled really well, except for two warnings, which is not coming from our end. It's coming from address upgradable. That's not ours, so that is just fine for us. So let's see what's next. So we have done step one. We have done step two. Make contract enable and possible. Initialize. Opens up available. Update wallet implementation. New wallet function. New wallet event. So I think we did not file the event, which is now emit new wallets. As you would see soon, this is why are we having this? Okay, we don't have the events defined yet. So we need to define an event that says event new wallet, which says string memory UUID and no, I don't think we need this UUID and address wallet. And the purpose is that, I mean, once you create a new wallet, you want to just listen for the events to see that things work, and this will help us in our test too, or in our test. And we can use this to, again, if you are trying to connect these to things like graph protocol, you can always use this to get your data updated and all. So new wallets, UID, comma, wallets. Wallet UID. So again, that's just fine. We'll flesh out an implementation function, remove proxy as abstract owner in exchange to common wallets. Which we've already done. Add that console. We'll do that later. We could just have that now. Let's have that now. For example, I really just want that to use as tracking. Next step we want to do is just write our test. But before doing that, I want to add some logging. And this cannot be overemphasized. Let me do this import first and this. With this proxy work, it's simply just, fantastic. Right here we say anybody that calls our proxy, which is anybody trying to interact with our wallet smart contract, right, needs to be our factory. If you are not our factory, no, you can't. All right. Um, and when we deploy our proxy, we already know our factory. So our factory will always be our factory forever and ever because our factory too is also an upgradable smart contract, as we see, right? And okay, let's be clear about this. If we are calling our proxy, you actually do not have to be our smart contract to call our proxy. So I'll comment this out. You actually don't have to, because if we are going to go this route, it means that all of our calling needs to be routed through this, which we don't want to do, right? So we are going to start from here to log it down, which is if a function is being called on a smart contract, all right, we'll do our fallback here. We want to trace how all of this work. So console.log, yeah, console.log fallback code. Remove this like shortly. Fallback code. Next now is being called is implementation to get implementation, which is right here for implementation code, implementation, and then delegate code. All right, so now let's start writing our test. So the first test that we're going to write is, we should test that we can deploy new wallet. Well, first I want to see if we can check that the implementation address is actually correct. All right, so let's do that. Let's just confirm that the implementation address is actually being set. We'll start from that. We'll start from something that simple before we now deploy wallets. I will try to write minimal test as much as possible, and you can go ahead to flesh things out and add more. So let's just change this to exchange for test. We have respect. We have this already. Let's say we call this exchange. Right. So we want to first check should have the correct wallet implementation. So usually what I like to do is I like to set things out when I try to have like a before all, which is something like this function is right. Okay. Again, let me just do this constant signer one, signer two. Let's get our two signers from there. Does dot get right. Let's test things out. I do not need all of this, so I could just simply just keep this. Let's see if our test just works. Now, before we run before any of our tests work, and what I simply want to do is try to set things in place. Like for example, deploy our wallet implementation. Like if we are going to use ADATs, like ADATs, in ADATs, it is like something synonymous using like fixtures in ADATs where you can like set some default. But in this case, I like to do this way. It works fine for me. So let me see, signer one. Yeah, let's just see. I'm actually skipping this test. So NPS ADATs tests. Let's change this. So let's see how that goes. Let's see the console log the address. Let me do that. So let's see. I think I might be getting something wrong here, which I want to solicit here. Moment right here. Let's check how that's. Yeah, sometimes get signers. I forget that it's just a thing with me. So let's see. I'll just copy this over and that should work. Yeah, it's the same thing anyway. Except that I'm not doing await, which is why it's causing the issue. Sync and yeah. Wait. Let's take that for a spin again. All right, yeah. Now, first thing that we want to do here is, yeah, we say our before we can deploy what we call our wallet factory, we need to first deploy our wallet implementation right here, which we can say, okay, our wallet implementation right here, or simply put this, which is dot wallets imp. And again, why am I doing using this here so that I can access it outside, like inside of here? I just want to deploy one and use it so we can build on it. Is if I'm correct, is simply called wallet implementation right here. I don't need this yet, to be honest. I just need. Actually, we need it. Let me stick it this way. Then this dots wallets imp equals dots deploy, right? Now that that is deployed, we need to do the same thing for the factory. Let's say, okay, this dots Test factory. Yeah. Um, Remember, this guy is an applicable contract, and I mean, if you actually want, if we want to actually test for like the whole upgradable system and everything like that, which we are not doing right now, we are not going to cover in this workshop. You would want to probably do this in a different way. There are LPAS that others provide, helps that people provide to do this, but yeah, we just called initialize ourselves. So we'd say this dot s factory dot initialize, and what we are passing to it, remember,
Okay. We are using the established time. So to speak quickly.
are you saying something, Andy?
Oh yeah, we're a little bit above time.
Okay. Yeah, I would just write two tests and then we'll be done. Right, yeah?
Awesome.
Okay. And then everybody can make reference to this code base and do the test. I just want to like write two tests and do this, or just a test. I'll just write a single test basically. Just check for the version. So here we have this will just initialize right here, and we have to await this to happen. So we can just should have the correct implementation. So right here we can just say uh, we constant implementation equals this dot factory first factory dot wallet implementation here, and we can now wait this, and we can expect implementation to be equal this dot to address. Let's run that, see how that works. Oh yeah. Wrong artifacts being passed here, so it should be. Let's change this. Let's run it again. Initialize public initializer. Let's see that. So Unamdi, I would like to kind of like stop this here. I will only be able to write this one test because it will take like a bit while longer, and like the code base and the test and everything is already like available right here. that works. So let me just await this anyway. So like viewers can you know viewers can take a look at this and use it to follow through in order to like understand how all of this like really works. So thank you guys. Tomorrow we'll be holding this session to talk about how you can build the backend. And in case you have like any question by tomorrow about how all of this works, then you can bring a question.
Thank you so much, Barry. Thank you everyone for coming in. If you have any question, this will be the time to drop it in the comment section.
All right.
In the absence of question, thank you everyone for tuning in, and we'll see you tomorrow at tomorrow's workshop. Bye, guys.